All right, the next lesson that we're going to do is called factoring perfect square trinomials. All right, we've worked a little bit on this because we've done radicals already. And when you square a binomial, remember, if you have a square on the outside of a binomial, that 2 means that you are actually going to get 3 terms because you get one more than that exponent. So we talked about that too. It's like a shortcut so that you'll know exactly how many terms you're going to get. So we always just write 3 blanks. You're going to square the x. You're going to square the positive 5. So you'll get positive 5 times positive 5, which is positive 25. Then we multiply 5 times x and get 5x, and then we double it. So that means times 2. So there's actually 2 5x's, which will give me 10x in the middle, positive 10x. All right, if you multiply this, again, that square means you're going to get 3 terms. And if you square the x, you get x squared. We're going to square the negative 6, so it's negative 6 times negative 6, which is positive 36. Then we're going to multiply these 2 terms. So that's x times negative 6 is negative 6x. And then we're going to double it. So that means times 2. So negative 6 times 2 is negative 12x. Now what we're going to do this time is we're going to go backwards and we're going to have this as our problem and come up with that part where the binomial squared. That's going to be our answer. Okay. So just like before, you had rules for factoring a difference of 2 squares, which was just a binomial. All right, you're going to also have rules for this. All right, so the first thing that we're going to look at is the common factors. So you always, always, always bring the common factors out first. All right, so our rules this time, we're going to be looking at, first of all, a trinomial. Your first and last terms have to be perfect squares. And of course, we made our perfect square list on our other sheet. And just to refresh your memory, I'll just write down some of the perfect squares that we had before. We had 1, we had 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, and so on. And you can write, as far as you want to write. All right, so we have the first and last have to be perfect squares. Remember, if it's an exponent, you have to have even exponents if they're perfect squares. All right, then the third term, for this shortcut to work, the third term also has to be positive. And then once we get it factored, one more thing that you have to do is you have to make sure that the middle term will check. And we'll talk about that in just a minute, okay? The middle term has to check, okay? So we will talk about that in just a minute. All right, so those are, I guess, what I call the rules, or the things that you have to look for. All right, so let's now look at a couple of problems. Now, the other day in class, we had a couple of these that we had to look at, and I showed you real quick how to do this factoring, but hopefully this will make a little bit more sense now because we're not going to have to go quite as fast. All right, so the first thing that you're going to do is you're going to look for, again, the common factor. All right, well, this is a 1, so I know there's not going to be a common factor for the numbers, and there's not an x in all 3. So as far as the common factor goes, we don't have one. All right, so it's a trinomial. So I always try to make it easy by training myself to look for perfect squares first. You're going to have other trinomials that we're going to have to factor, but if you will train yourself to look for perfect squares first, then if it is a perfect square trinomial, that'll just make it that much easier and quicker for you to do. So you look at the first and third term and see if they are squares. Well, that is because it's an even exponent. And I know that 64 is because 8 times 8 is 64. And remember I told you that the last term had to be a positive or a plus. Okay, so we know all that. So we're going to assume that it's a perfect square trinomial for right now. Once we do the check on the middle, then we'll know for sure if it was one. So this is real easy. You do the square root of x squared and you get x. Then you do the square root of 64 and you get 8. And you put it in both parentheses. If this is a positive in the middle, then you put plus plus. Now when we did difference of squares, it was one positive, one negative, because I kept telling you guys, you know, the middle is going to cancel out on these. And then finally you guys realized the middle cancels out when it's a positive and a negative of the same thing. Well, this time the middle doesn't cancel out. We have a middle. Okay, so now we're going to check and see if that middle is correct. So all you need to do is check the two smiley faces. So I'm going to make one here. That's going to be 8x. So 8 times x is 8x. I'm going to make one here. X times 8, it's still 8x. And then I'm going to add those up. 8x plus 8x is 16x. If this number is the same as that middle number, then you know it's factored correctly. So I know that this times this is x squared. 8 times 8 is 64. And then 8x plus 8x is 16x. Okay, so there's also a short way to write it. Since these are exactly the same, you can write one parentheses with the x plus 8 in it and a square. Now on our SOL, it will possibly have both of those things. You may have x plus 8 quantity squared, and you may have x plus 8 times x plus 8 as the answers. And if that's the case, you will have to click on both of those answers. All right, number 5. It's a trinomial. We're going to check for common factors. Okay, I don't see any common factors. There's common factors here. I know 5 goes into both of those, but it's not here. This is just a 1. There's not an m in everything, so there are no common factors. All right, so we're going to check for perfect squares because that's all I need. That's all I know to check for right now. So yes, that's a perfect square. That's a perfect square, and the n has to be a plus. So since that's the case, you write 2 parentheses. You do the square root of m is m. The square root of 25 is 5 times 5. And then I told you to use this sign, so it's going to be plus plus. Okay, so I'm going to check the smiley faces and see if we get 10m when we put those together. So this is going to be 5 times m is 5m. 5 times m is 5m. Add those up, you get 10m, and that's the same thing as the middle. The short way to write it, you write m plus 5, quantity squared. All right, number 6, common factors. All right, let's see. Nope, that's a 1, so we don't have a common factor. We do not have a p in everything, so we're going to check for perfect squares. That's 1, 64 is 1, and this is a plus sign. So I'm going to write down 2 parentheses. Now the only thing different in number 6 and number 4 and 5 is what? Hopefully you have looked at this and it's got a minus in the middle. That's the only thing different. Okay, so I'm going to show you how to take care of that. So p squared is p times p. 64 is 8 times 8. And since this is a negative in the middle, it has to be negative negative. Okay, so now we have to check and see if this actually gives us the middle. All right, so this is going to be negative 8p, negative 8 times p, negative 8p. This is going to be another negative 8p. Well, negative 8p and negative 8p is negative 16p. But my middle term is negative 8p. So these are not the same. Therefore, I cannot factor this like this. There may be another way to factor it, but I haven't taught that yet. So right now, we're just going to say can't factor. Okay, so we haven't gone over any other methods. So right now, we'll just say you can't factor. So you can just actually X that out and write can't factor. Okay, let's look at a few more because I don't know that that's really enough for me to go over. So let's go to 5-minute check number 13, and we'll just, you've got the rules and everything on the other paper, and you know what the perfect squares are by now. So let's go to number 4 on that page. Now notice, we've got A's and B's in this one, and the numbers are a little bit bigger. And on the SOL, I think they will even be bigger than this. So some of those big perfect squares that I was telling you that you might need to write on your paper, it's probably going to be to your advantage to do that. Okay, so let's see. Do we have a common factor? Well, let me see. A 16, a 40, 25 is going to be 5 times 5. 5 goes into 40, but it won't go into 16. So I don't think we're going to have a common factor. Is there an A in everything? Nope, just in 2. Is there a B in everything? Nope, just in 2. So I do not have a common factor. All right, so let's see if we have perfect squares. So yes, that's a perfect square because the square root would be 4. 25 is a perfect square. That would be a 5. This, of course, would be just A, and this would be just B, and that's a plus sign. Okay, so I'm going to automatically write my 2 parentheses. I'm going to look at 16a squared. Square root of those would be 4a. Square root of 25b squared would be 5b. And since this is a minus, you're going to put 2 minuses. So on the trinomials, when they're squares, you'll put either plus plus or minus minus, because this sign times this sign has to give you that positive 25. So you have to make sure that you put 2 minuses on that. So it gives you the positive 25, and then if you check the middle, this will be negative 20. Since this was A first, we usually write, instead of BA, we'll write AB, just like that middle is, AB, since that A is first. And then this will give me another negative 20, AB. Well, negative 20 and negative 20 is negative 40, AB. So that means it's the same as the middle, so I know that's correct. So the short way to write it would be 4A minus 5B quantity squared. Now, I can't do anything else to this minus. Remember, you have to check and see if you have squares. I didn't really talk about that on the other ones because they were pretty simple. But this one, we do have a square for the 4, but nothing else is a square. So that's all I can do. All right, so let's look at number 15. Now, number 5. Number 5, again, you're going to look for common factors. Well, I don't have any. And as far as I know, for trinomials, all I'm looking for right now are perfect squares. Yes and yes. And the end has to be a plus. Well, this end is a minus. So for right now, I can't do this. So we're just going to write a can't factor, because that I can't use perfect squares on it, because that right there is a negative instead of a plus. Has to be a plus for a trinomial. So that would be all for number 5. Okay, let's look at number 6. Number 6 is r squared plus 4r plus 4. Okay, so the first thing that you're going to do is look for common factors. It almost has common factors. It's got 4's here, but not on the first one. So we don't have common factors. No numbers are common. We don't have r's and everything. So we're going to check and see if they're perfect squares. That would be a yes. The 4 is a yes. That's a plus. Automatic, 2 parentheses. Square root would be r and r. Square root of 4 is 2. This is a positive. So you know you're going to have plus plus or minus minus. So right here will tell me to put 2 pluses. So we're going to check and see if the middle is 4r. So this is 2r plus another 2r is 4r. So that works. So that could be also written like this, r plus 2 quantity squared. All right, go to number 7. Is there a common factor? Well, I've got a 9 and a 30. So I know 3 goes into both of those, but not into 25. And n is not in everything, so no common factor. All right, do we have squares? Well, that would be a 3. That's a yes, and that's a plus on the end. So we put 2 parentheses. Square root of 9 and n squared will be 3n. Square root of 25 would be 5. This middle is plus, so we know we use plus plus. And then we check the middle. So 5 times 3n, 15n. 3n times 5, 15n. Add them up, you get 30n, and that's what the middle was.